We discussed in a previous section that linear equations can be used to model real-life situations, and when working with such scenarios, you will often hear the term rate of change used. But the rate of change is simply referring to the slope of the line represented by the linear model. Now, sometimes you will be asked to find the rate of change per unit or per year or per something, and in that case, that's one of those application scenarios that I was talking about in a previous video where you may want to write the slope as a decimal because you're asked to do per 1 unit or per 1 year. So if it doesn't divide out evenly, then you would need to write it as a decimal to make sure that you're getting it per 1 unit per 1 year and not 3/2, which would be 3 units over 2 years or 2 units of some kind. So other than that, everything that we applied to slope, we can apply to rate of change, including the slope formula. So let's look at our example below and see if we can find the average rate of change for this model. So the following graph shows the relationship between the output of a factory and the cost of production. Find the average rate of change in output per unit. So this is one of those examples where we want it per unit, so we need to make sure that we divide so that our denominator is a 1. So what I'm going to do is choose a couple of the points that are on the graph, and I'm going to find the coordinates for those points, or the ordered pairs for those points. I'm going to choose this point and this point just because those are the ones that are actually falling on the whole number tick marks that I can use. So here I have an x value of 15 and a y value of 16,000. And remember, that simply means that to produce 15 units, it's going to cost $16,000. Now, I don't really know what I'm producing, what kind of unit. It could be cars, it could be bicycles, it could be, some type of a training program where you're producing police recruits, but we're producing something, and 15 of those units is going to cost us $16,000. Then we have this point here, which has an x value of 30 and a y value of 24,000. So again, 30 units, the cost to produce 30 units, whatever those units are, is going to be $24,000. So if I label this as point 1 and I label the second point I chose as point 2, I can plug these values into our slope formula and find the rate of change per unit. So our slope formula is m equals y2 minus y1 over x2 minus x1. So my y2 value is 24,000. Minus my y2 or y1 value is 16,000. X2 is 30 minus x1 of 15. So I end up with 8,000 over 15. And because I know I want it per unit, I'm going to divide 8,000 by 15. Not 80,000, let's try that again. 8,000 divided by 15, and I get $533.33 per unit. So the average rate of change would be $533.33. Now, because the cost is a monetary value, I rounded to 2 decimal places, even though it did not specify, because we always round money to 2 decimal places. And the beautiful thing about rate of change is that this actually means something. It tells me something about this real life scenario that I've got going on here. And what it tells me is that every unit that I produce as this factory, it costs $533.33.